how are these systems learning from their own predictions, from the data that they model out? Is there a feedback loop mechanism where they're learning from their own results along with the data that they're pulling in that's new?
I mean, in a way, you could say that we're 2 weeks from now, we'll be starting on things that like reinforcement learning. So you can say that it's learning from itself and its past trials, but to, in a way, how they're learning through time and that feedback is the model.
Can you repeat that?
So
How they're learning through time and cut out on
how
you?
they develop over time is up to us as the modelers. A lot of times is that the way to think about these is not that we just bought a distiller, a reactor, or a generator, we're bringing it online, now it's working, and we're tuning it. That's not really the way it works. This is something where every month, every 6 months, you're building it and you're building it and you're building it. It's kind of like a house, but you're building it one room at a time. And it might look like the same model because it's giving you the same output, but the feedback and the evolution are up to us, the modelers, to keep building new modules onto it, because these models start to get bigger and bigger and bigger. They're not just one thing that you didn't just buy a generator and then you're tweaking the parameters. You're buying it, you're making one, you're building another piece, another piece, another piece. Usually what you end up with in 2 years is nothing like what you started off in the first 6 months. So the feedback and the innovation is up to us at the Jacobson to just keep building on this. And I'll be honest with you, what we'll have in 12 months from now will be very different than what we had in the first 3 months, right? We just keep building on it. That's the feedback loop, is us building more.
When we think about an AI or deep learning, how often is that machine, how often is that process going back and revisiting the whole tome of data? Or is it?
Ah,
Is
yes.
it like the way I think about it, and I would, using a human analogy, is it would be like me going to my library in my home and rereading every book every day, or is it me only looking at the last three books that I've read?
So different models are different ways. Some models will just look at the most recent times. They'll put a much big preference over it. But with deep learning, they will look through all of the time, and they might put a preference towards the most recent. But the way the models learn over is, you're exactly right. When people are different in that we learn, we're constantly learning. We're always updating our past knowledge, our past training. But these machines are different. These machines, once we hit train, then we validate or test their training. But once we deploy them, their knowledge is kind of set in stone, right? The knowledge is set in stone. And that is why for most machine learning applications, you have to retrain them. You have to keep retraining them. And so what you're doing is you're putting in new information and then you're kind of retraining them again, and then they'll learn a little bit more about the new things. This is also where analysts are so important, is that what if the new batch in the last 6 months is Corona, and you know for a fact that this is not a regime where you want it to train on because it's a one-off area. It's a strange area, and all the past relationships of supply and demand don't matter here. There are these other animal instincts that, could vary it. But so what we will have to do over time is, we already do, is we will constantly retrain the models with new data that comes in, and it will learn. But that's exactly the case. Once it's trained and it's deployed, it's frozen. Its knowledge is frozen, and it's up to us to go back. And even if it's the same model, even if we didn't change much about it, we'll retrain it. And when it retrains it, it gets a reevaluation of those relationships.